Let's talk about arrays and lists. And here's a spoiler alert. Arrays are not built into Python. We're going to talk about them here because they are an important computer science concept, and they are built into other languages. And in fact, you can use arrays in Python, but you need to import a module first. In this lecture, we'll introduce the concept of arrays and talk about how we can use lists in the place of arrays. So an array is a fixed-length, homogeneous collection of objects. We've seen one other collection so far, the dictionary. And arrays and dictionaries are just things that can contain other objects. But let's look at these other two words, fixed length and homogeneous. These are restrictions on arrays that make them a little bit unflexible, but also very fast. So an array is generally stored in a contiguous space of memory. When I tell a language like C++, for instance, make an array of ints of size 10, C++ will first figure out how much memory it needs to store an int, and then how much memory it needs to store 10 of those ints, and then reserve a space in memory to store exactly 10 ints. Let's place some integers in here. The reason this collection is so efficient is because once we know the location of the number 2, we can find the next number in our collection just by skipping ahead one place. We know exactly the size of an integer, so we know exactly how far we need to skip ahead. We use something called pointer arithmetic to do this, and it's super fast. But with this efficiency comes these two restrictions. The reason an array has a fixed length is that we have reserved a place in memory. If we wanted to add an item to this array, we would need to extend the array out in memory. But remember that the array needs to be contiguous in order to be efficient. So we need space in memory that's located right after the last item in the current array. It's not guaranteed to be available. We might have put something else in there. So the array has to be fixed length. If we want to extend it, we may actually have to copy it all into a brand new array. Homogeneous means that each object in the array needs to be of the same type. If you have an array of ints, every single item has to be an int. We can't have some ints and some strings. Why is that? Well, again, we've set aside a certain amount of memory for this array. And if we'd like to change this first item from an int to a string, the string is likely to take up more room than the int. We don't have room to fit it in there, and we don't have room to make the array longer. Plus, remember, we wanted to be able to jump from one item to another by advancing a known length in memory. So that's the reason for those two restrictions. In Python, we have a collection called a list. A list is implemented differently in memory, and it doesn't have to have a fixed length, and it doesn't have to be homogeneous. So we can start out our list with 2 items, and we can add another item at the end anytime we want. We can take this first item, which is an integer, and replace it with a string. The truth is that lists are actually implemented as arrays inside Python, but a list is an array of references. So if we have 5 items in our list, each space in the list points out somewhere in memory. So the first item may point to an integer, and the second item may point to a string. The third item could also be an integer, maybe the fourth also. The fifth item could even be a dictionary. We can fit any size item into the list because of the fact that Python is actually just storing a reference in each cell, and references all take up the same size. If we want to change this fourth item, which would actually be item number 3, from an integer to something huge like maybe a very large dictionary, all we have to do is remove this reference, create a dictionary somewhere else, and point item number 3 now to that dictionary. That means that accessing items in a list in Python is almost as fast as accessing items in an array in C++. And changing items in the list is also very efficient. However, if we want to extend the list or insert an item into the list, it's a pretty expensive process in terms of computer time, because we likely need to create a whole new list, copy our list of references over to the new list, and then start using the new list. So let's see how we implement and access a list in Python. We'll do this all at the module level. We can create a list using a square bracket notation, and simply listing out the items that we want to include separated by commas. So let's start just with integers. We have a list of 4 items, 12, 3, 2, -1. And remember, PEP8 wants us to put a space after each comma. Accessing items in the list is pretty easy. We just use the name of the list, followed by square brackets, and then the index number of the item in the list. Remember that indexes start with 0. So this is index 0, 1, 2, 3. If we want to access the 3, we would use index number 1 to print it out. Let's make sure that works. Great. If you remember when we accessed strings, we could start from the back end of the string, and we can do the same thing with lists. If we want the last item of the list, we can use -1. We can iterate through a list using a for loop. And we can replace an item in the list using the assignment operator. If we want to replace the item at position 2, we just use the square brackets with the 2 inside. And remember, we're not restricted to replacing this with an integer. We could replace that with a string. Let's print the list again. And we see that our string got inserted just fine. We can check whether an item is in a list using the in keyword, just like a dictionary. So because there is a dog in my list, this condition evaluates to true, and we print there is a dog. There is no cat in my list, so this condition evaluates to false, and we print no cat. We say a list is a mutable object because we're allowed to change an element of the list without actually replacing the list itself. If we print the ID of my list before we make a change, and again after, we find that it's the same. Changing an element of the list did not change it. But if we reassign the entire list, we find that it has a new ID, meaning that MyList now points to a completely different object. The original MyList is destroyed because there's no name that refers to it. We can append to a list using the append method. And we see that 15 was tagged on to the end of our list. There are more advanced things we can do to access and change a list, including something called slicing and list comprehension, and we'll explore those later.